Example question number 10. The two resistance are given as R1 is 100 plus or minus 3 and R2, the resistance, second resistance is given as 200 plus or minus 4 ohms. Okay. Now, when they both are connected in, there are two cases. First case they are connected in series. Second case they are connected in parallel. And what we are supposed to find out is find the equivalent resistance. Okay. So, they have specifically given one relation that delta RP, that is resistance in parallel, the effective resistance, divided by RP square is equal to delta R1 divided by R1 square plus delta R2 divided by R2 square. This is given. Okay. So, they are asking us to use this relation. So, first we will consider this first case that they are connected in series. So, we know that when the two resistors are connected in series, the effective resistance will be R1 plus R2. Clear? So, first the resistance in series will be, I have written as RS, R1 plus R2. So, what is R1? 100. 100 plus or minus 3 and R2 is 200 plus or minus 4. Therefore, 100 plus 200, 300. Okay, so 300 plus or minus 3 plus 4, 7 ohms will be the effective resistance when they are connected in series. That's it. And the second case, they are connected in parallel. Okay, so they are connected in parallel. When they are connected in parallel, you know that 1 by Rp will be 1 by R1 plus 1 by R2. Okay, first let me find out the effective resistance when they are connected in parallel. Okay, so 1 by R1 is 1 by 100. So I can simply write this expression as R1 R2 divided by R1 plus R2. So this you might have studied in 10th standard itself. So which is R1 plus R1 R2 will be, so simplify, after simplifications R1 and R2 will be 200 into 100 divided by R1 plus R2 will be 300. Okay, so after simplifications I'll get the answer as 67.1 ohm. So this is the effective resistance when they are connected in parallel. So now they say, now it is given to use the special relations to find out the error. Okay, so to find out the error R dash. So for that delta R dash I should find out. Okay, so delta R dash I should find out. They are telling to delta RP. Delta RP I am supposed to find out. So using this relation, it is a given relation. So delta RP is written as RP square into delta R1 by R1 square plus RP square into delta R2 by R2 square. It is given to use this relation. Okay. So RP is how much? 66.7 the whole square into delta R1. Delta R1 is 3. 3 divided by R1 will be 100 square. 100 square plus RP is 66.7 the whole square. Delta R2 is 4 divided by R2 is 200 square. Okay. So after this is after simplifications. So you can take 66.7 the whole square as common and then take the LCM and then simplify it. You will get the answer as 1.8. So delta RP as 1.8. So the error in the resistance, the effective resistance will be 1.8. Okay. So now what happens to the total resistance in parallel, that is RP. Okay, the effective resistance when they are connected in RP will be, already I got 66.7 and the error is plus or minus 1.8 ohms.